I'm going to first go through the first 2-3 slides, what I mean by existential threat. Then spend the next third of my time walking you through the science which led me to this disastrous conclusion. So if you forget everything I say about climate change, I would like you to remember this one thing. Climate change can reach crisis levels this century, affecting everyone, rich and poor. The thing many have not realized, it's an urgent problem and requires urgent solutions. The solutions which are being proposed are phenomenal, but they don't have a clue about how urgent the problem is. Okay? So to indicate you how urgent it is, I want to walk you through the process I went through in not working full-time on the science, but on the solutions. These are the 3 reasons, my grandchildren. So the last guy, his name is Ian on the left side. The reason I put the slide third, normally I end with this. I gave a trial of this talk at Santa Cruz last week, exactly last Thursday, in a public talk, not an academic setting. I invited my grandson. I thought he wouldn't last through the end of my talk, so I put this third, so he will be awake for this. So let me tell you what he's going to see as he grows older. This is sort of the probability distribution as a function of the warming, end of the century. He's 5 years old, okay? By the time he turns 15 to 17, I have an uncertainty of 2 years. The climate would have warmed by 1.5 degrees. And I'll later show you, you should be very skeptical of anyone who makes prediction like this. But I'll show you where my track record in prediction. So you can ask, what is it, 1.5? The planet has already warmed by 1 degree. If you want to go back an analog for a planet warmer than 1.5 degrees, you have to go back 130,000 years. That time, it's called Eocene. The planet was warmer by about 1 degree, not even 1.5 degrees. Sea level went up by 6 meters. And those of you fellow Americans, that's 20 feet. I'm still a Fahrenheit feet person. And by the time he turns 35, that's 2050, I'll show you later. Sorry, this will happen by 2030, 1.5. By 2030, we would have already put enough pollution to heat the planet by 2 degrees. So that's the lead time. So by 2050, he would drift into a 2-degree world. And IPCC has called anything greater than 1.5 degrees dangerous. Okay? And I take my grandchildren to the beach and then talk to them about climate change, how they have to start working on solving the problem. So I can't think beyond 35. You drift into the question of existential threat. So what is this red curve? This is if you follow business as usual, what IPCC and 1,000 other modelers are saying that you will see a 4-degree warming. You're very careful about that, but what's not clear to them. Our models or our understanding of the Earth system is such that you don't know these things for certain. All we know is that there is a 50% probability the warming will reach 4 degrees. But there is at least a 10% probability the warming will be half as large, which will be good for us. The sad thing is, there is an equal 5-10% probability the warming could be 6 degrees. Okay? And what is the 5% probability? There's a 1 in 20 chance we will be facing catastrophes. And would we get on a plane if somebody says there is a 1 in 20 chance it's going to come down? But we are willing to send our children and grandchildren on that plane. And there is a 1% probability, which is still too high, of 8 degrees. By the time then, we have no analog. You've got to go back to the Cretaceous time, which wiped out the dinosaurs. So that's what I mean. So I categorized this and I later justify it. I sort of took the courage to say, okay, the dangerous is 1.5 to 3. Then you drift into a catastrophic domain, 3 to 5, and then go to the unknown. To me, the unknown is the existential risk. And I put question mark. I'm giving this seminar today and tomorrow at Oxford. If there is no pushback for the subsequent talks, I'll remove the question marks. All right. I finished talking about what I meant by catastrophic. Okay. So what I mentioned is that, let me go back to the urgency problem. Why am I saying it's an urgent issue? By 2030, that's just 13 years from now, the planet is going to reach 1.5 degrees. And such a planet existed 130,000 years ago. So a degree warming for the planet is a huge amount. And by 2 degrees, it's going to go past 2 degrees by 2050, which everyone agrees is a dangerous territory. I'm now categorizing 3 to 5 as catastrophic, and then beyond 5, I'm calling it unknown, which is what I imply by existential threat. So the first thing, how do we solve this problem? This is all the influence of the Vatican on me, and then this conference, Partha Dasgupta and I recognized. We have to now, we are in this together. This is just not a statement from a social scientist. I'm going to show you a remarkable video which will show you from a natural science point of view, why is this a problem in all this together. You're going to see how the atmosphere moves pollution around. Just watch from China. Pollution from China goes into US in less than 3 to 4 days, about 5 days maximum. So while the Chinese are sending their gift to us, we Americans send our gift to you in less than 3 days. That's all it takes, okay? So when you make measurements with pollution, particularly go above 0.5 kilometer, you're seeing pollution from all over. And then look at South America from Brazil. Biomass burning dives into the Antarctic in 3 days, okay? So now let's see, that's how a local problem becomes a global problem. So 2 days ago, I drove, took me an hour and a half from Oxford to Cambridge. What came out of my tailpipe, the fuel is hydrocarbon. The carbon burns with oxygen, becomes carbon dioxide. 50% of that carbon dioxide would be there when all the students here, when your grandchildren is of your age for 100 years. And 20% stays for 1,000 years. So the CO2 which came out of the brilliant British engineer Mr. James Watt's steam engine is still there. Okay? So it covers the whole planet like a blanket. All right, so let's talk about the nature of this blanket and why we should worry about this blanket. So since 1750, we have added 2 trillion tons of carbon dioxide. Okay? And look at that atmosphere, it's so fragile. And that's what keeps us alive. So out of the 2 trillion tons, 930 billion tons is still there. So that's the thickness of the blanket. Imagine that, that's virtually equal to 450 billion cars circling around the planet. If it was there like a solid, you would all see it. Unfortunately, it's a gaseous form. That's why people are able to dismiss this as junk science. So why should you worry about this blanket? So I'd like you to take you to your bedroom. On a cold winter night, you cover yourself with a blanket and you feel warm. Why is that? The blanket is not giving any heat, it just traps your body heat. You know, your body on average produces 100 watts of energy. There is a 100-watt light bulb inside you giving off energy. Same way, the planet gives energy, emits energy as infrared, And not all of that energy escaped to space. It's trapped by this blanket. Okay? So before we blame everything on CO2, nature gave us a thick blanket. And let's just see why that's important. I'm now condensing my 1/4 climate change course into one slide. Okay? So it's a cartoon of the blanket. You see my bias and prejudice. I drew North America, didn't draw Europe. Okay, sorry for that. Next time I'll change it. So think of the energy you get from the sun as 100%. That's what heats the planet. Okay? Then the planet heats up, gives off this energy, the infrared wavelengths, the radiation you see with your infrared camera. So this process goes on until what comes in as sunlight goes out as infrared. Not all of the 100% is absorbed by the planet. 30% is reflected. And we call that albedo. I'll conclude with this slide why this could push the planet into a different state. Anyway, the 70% is absorbed. And if the planet emitted infrared, if there was no blanket, the planet would be frozen like Mars. So nature gave us a blanket in terms of water vapor and CO2. CO2 is also a naturally occurring gas. That's what warms the planet from a frozen to the temperature we enjoy. So greenhouse effect by itself is not bad. What we are doing is thickening the blanket, right? So until about 1975, scientists thought carbon dioxide is the only man-made greenhouse gas. Remember, I was at that time still in engineering with the Impala dream. So I didn't read any of these papers which said, don't worry about any gas other than CO2. I had seen this paper in 1974 by Molina and Rowland. They got the Nobel Prize thanks to the discovery of the Antarctic ozone hole by the British Antarctic Survey. So I was curious because I learned quantum mechanics and I knew any polyatomic molecule is a good greenhouse gas. So I looked at the greenhouse effect of CFC. They were used as refrigerants and propellants. It came as an absolute shock to me. It was 10,000 times more potent. I experienced the same shock after 42 years, 4 years ago, when I realized we are slipping into an existential threat situation. The Montreal Protocol, which banned CFCs, they did not recognize the greenhouse effect of CFCs. They banned it because of the effect on the ozone layer. And it took me 41 years. It was in 2000, what they did was they replaced it with a gas which did not attack ozone, but still was a super potent, it was 1,000 times more potent than CO2. So we solved one problem, created another problem. So we worked on the Montreal team, and finally, last year, the Montreal Protocol was amended with what's called Kigali Amendment. So they banned HFCs. It's the first treaty which recognized climate effect is something to worry about. So it's a historic change, even more than the Paris Agreement. So the thing is, this was 1980. By this time, I knew my Impala dream was gone, and I realized the greenhouse effect was a serious issue. So the question we were curious is, when are we going to see this? See, if it was CO2 by itself, it would be half the problem. The addition of all these trace gases made it twice as important. So I teamed up with a meteorologist, famous meteorologist, Roland Madden. There's an oscillation, Madden-Julian oscillation, named after him. So we did the signal detection analysis, noise to signal, and we came to the conclusion, if this theory is credible, it has to be detected by 2000. Remember, any scientific theory can be validated by its predictions, right? So this is the global average temperature record starting from 1850. Mind you, when we published our paper, the planet was still a little bit cooling. So I remember my colleague said that we were absolutely crazy too, because people are thinking the planet was on a cooling trend. Then if you look at the record in 2000, yeah, that's when it rose above the noise. And I'm giving you as an example to let you know there were many predictions like this which were made. They all come true. I don't know why IPCC doesn't mention this. They're just so busy using the models projecting the future. And that is why our science has become, to be attacked. And so, we know, and I'll tell you others, they're all coming true one by one. So it's based on such physics where I'm saying we're going to see 1.5 degree warming by 2030. Now I want to walk you through the science which led me to the existential threat question. So when I was after my graduate degree in Mars and Venus, I couldn't get a job. I went back to India and I tried to persuade my father that understanding Mars and Venus is very critical. And after 2 weeks he told me, you better go back to US. Only Americans can afford to pay for such theoretical work. So I came back to the US, joined NASA. We designed a satellite experiment to measure this albedo and heat flow from the Earth. I was very interested in measuring the greenhouse effect directly. Later, we moved on to looking at the whole pollution with unmanned aircraft, drones. They're just about 2 meters end to end, and the miniaturized instruments. So I'll show you what we found out from that. One of the biggest elephants in the climate change is what's called water vapor feedback. Okay? Remember I told you water vapor is a powerful greenhouse gas. So let's go back to the bedroom metaphor. You had a blanket, it kept you reasonably warm. But you put one more blanket and you get more warm. How does your body ventilate its heat? You sweat. What happens when you sweat? You evaporate moisture. That's cooling. That's exactly what the planet does. The oceans evaporate more, and it's governed by a simple thermodynamic equation. There's no modeling involved. It's basic physics and thermodynamics. Every degree rise in the temperature of the water increases evaporation somewhere between 6 to 15%. You can test it. Put a pan of water on your thing, have an instrument, you can measure it. But the problem here, the ocean says, I'm too hot in evaporating moisture. But the ocean, I think, doesn't know quantum mechanics, that water vapor is making the blanket thicker. And it gets warmer, it's evaporating more. So that amplifies the CO2 warming by a factor of 2. Okay? Force multiplier. So far, so good. But this water vapor feedback was proposed by Svante Arrhenius, who was the famous father of physical chemistry. He took a year off to understand climate change. And I wanted to measure this. So I thought, look at the ocean off of Australia. It's the hottest ocean anywhere in the planet. So I thought, if I need to understand the warm world, I need to understand the warm pool. So we took that instrument telescope, measured the heat flow coming from the cold ocean to the north top. Okay, I know the heat escaping. All I need to know is what's the heat coming from the ocean. That is governed by a simple law of Planck's radiation. So its temperature is 4. So I, from the ocean temperature, determine the heat coming from the Earth, and then my satellite is measuring what's escaping the top. And we published this in 1989. It's a direct verification of what Arrhenius ingeniously deduced. At the top, I'm showing the temperature of the ocean. The bottom is the infrared energy trapped. Look at the perfect correlation between temperature of the ocean and the thickness of the blanket. Where is the blanket thickest? In the warm pool, where the ocean is warmest. Okay? So that confirms this and other things. The water vapor is amplifying by a huge amount. Except what we saw was that in the warm pool, it went into what we call an unstable mode. It was evaporating too much moisture. After about 30 degrees Celsius, the evaporation takes over. So the heat has to be shipped to the rest of the planet, escape to space. So now take this curve, warm the planet by 6 degrees. That red area would go to the southern tip of England. Okay? That whole area would expand. So now half the planet is in this super greenhouse effect mode. That's one. So, but we found something very peculiar. The sunlight reaching just north of Townsville, Australia, was a lot less than what our model was predicting. And the only way that could be explained, there was some dark substance in the air, blanking the sunlight. So we launched the experiment in the Indian Ocean. It started a small experiment on a ship by Paul Crutzen and myself, and it grew into a 250 investigator experiment with 6 aircraft from the Dutch, the German, the French. India sent a ship. And to our surprise, we found that dark substance was the black carbon soot coming from diesel. And the biggest shock for me was that about third or fourth, about 40% was coming from firewood burn. And on the last day we were doing the experiment in Arabian Sea. I went to Bay of Bengal. I flew by my village with a C-130 aircraft. I still can't forget that day because we were going to fly over Sri Lanka. And it's an American plane. It turned out the Sri Lankan Tamils were aiming for our aircraft. So I told my American pilot, tell them I'm a Tamil, maybe they wouldn't save your aircraft. We couldn't, so we had to go around. And I saw my entire village, the whole South India, blanketed by this brown cloud. And that's when I think it was perhaps because I'm Indian, I decided I cannot leave this problem. I have to figure out how to solve it. And there was another thing, apart from the Vatican Church. Anyway, with the UAV, we found out that plume is going all the way to Himalayas. I'm now in an aircraft about 25 kilometers south of Mount Everest. So I'm looking at Mount Everest, and when I looked south, the entire mountain was covered by the brown clouds. And we later found out it's settling on the glaciers, melting the glaciers. What I'm trying to tell you here is there is a global problem, and every region I look at, there is some local problems going on. So that's why I consider most of the papers I wrote until 2004 were really obituaries. So now I'm ready to, I have 2 more obituaries, then I'm going to go to new births. The other bizarre thing happening, I think Charlie might have talked to some of you about this. Sea ice is retreating. We know that 40% of the sea ice is gone during July, August, and September. But the problem with the sea ice retreating, look at how white it is. The white substance reflects sunlight. The dark substance absorbs more sunlight. Okay? So when you retreat the sea ice and expose the dark ocean, your absorption goes by a factor of 2. Huge multiplication. And you can see how the sea ice retreated. We are looking at remember the satellite I showed I helped launch. So we looked at these periods. The increase in the absorption of the sunlight by the Arctic is equivalent to 250 billion tons of CO2. That's how things are getting amplified. These are all data, nothing to do with models. This is happening. Okay? The last thing, I know anytime I talk to my British English colleagues, they always complain about the weather. I want to give you good news. You are helping the planet keep cool. Tell you why. This is what we call extratropical storm track clouds. It starts about 45 north and goes all the way to the pole. These clouds are the whitest substances we know. They reflect so much sunlight, and I was shocked to find these clouds are retreating polewards. Okay? Not too much, about 200 kilometers they've shifted over the last. And to give you the magnitude of if those clouds were to disappear, retreat all the way into the poles, the increase in sunlight hitting the ocean is equivalent to about 10 to 15 trillion tons of CO2. So this is the kind of thing we are playing with. Okay? I talked about purely physical side of it. There are similar things going on the chemical side, biological side. This paper just came out 3 weeks ago. Oxygen content of the ocean is decreasing. They measure the oxygen content from 100 meters to 1,000 meters. The decrease, fortunately, is only 2%. The bottom one shows the decrease. See where the Arctic region, maximum depletion oxygen. Why? Because the sea ice retreating, more sunlight coming in has stabilized the top boundary layer. So there's no circulation to carry the oxygen from the air to the deeper waters. We don't know what will impact the species at 2% versus 10%, 20%. I know as human beings, we can live in 70% oxygen because we go to ski high mountains, right, where oxygen is low. But we don't know how we are messing up with the ecosystem. And then you combine this, what Partha Dasgupta and his colleague Raven are working on extinction. What is this doing to the extinction story? So it's not just climate change anymore. Everything is connected. This is some of the weather disasters, extreme weather disasters. Just in 3 years, you all know 2003, European heat wave, 70,000 died in the most advanced country. How come they didn't find air conditioners? So then you talk about the developing nations. Just in 3 years, in the famine, the drought, in Africa, African Horn of Africa, 250,000 just died 2 months. And so on and so forth. The heat wave in India, Pakistan, 4,000 died. We are expecting all of this to increase tenfold. Do you know, in the last 30 years, the so-called 3 sigma events, right? Less than 1% event of warmer than 3-4 degrees has increased tenfold. They're occurring 10%, not 1%. So, impact on the human health. Let's be extremely selfish. Let's not worry about the species, let they die, but how about us? And this study was published, a former student of mine, he's in Australia, Stephen Sherwood. They showed that if the limit of heat stress we can tolerate, but heat stress is just temperature, humidity. You have to live in India to know it's not the heat, it's the humidity which kills you, right? So right now, apparently body needs, our internal temperature is 37 Celsius, and the skin is 35, that's where the heat is escaping. So you increase the air temperature more than 35, you go to hypothermia. It turns out that extreme temperature doesn't occur anywhere in the planet. And they found if the planet warms by 7 degrees, about the third of the planet would be inhabitable, unless you are willing to air condition entire tropics. Okay? So the human health issue we should forget. So quickly moving on, now I'm going to say, why did I come to that dangerous, catastrophic, and existential threat? This is the so-called burning embers diagram. Came up with IPCC, and they categorized from 0 to 5 degrees. Why did they stop at 5? They don't know what's going to happen beyond 5. That is where my unknown comes. But by the time you go to even 3 degrees, all the things are at high risk. The purple is very high. And what is that purple? That is extinction, biodiversity loss. So there is biodiversity loss happening independent of climate change, just habitat destruction. And then you're adding this. That's what we mean. Remember, systemic risks don't happen by one thing failing, multiple things failing at the same time. So that is my final justification for this. So now let's talk about who is responsible. See, I had never asked this question in 45 years. And this fateful meeting with Dasgupta I decided I'm not going to do any more meetings with Dasgupta. It depressed me even more. So we proposed this meeting, Sustainable Nature, Sustainable Humanity. We submitted to the church, and the church loved the idea, but they added 2 words, our responsibility. And then that started a new research for me. Who is responsible? I found out I was the villain I was looking for the last 40 years. Half the pollution comes from the top 1 billion. Unsustainable consumption of coal, oil, and gas. Contrast that with the poorest 3 billion. I was living in her guest house, and that region suffered a drought. So her husband had to leave the village, go 300 kilometers to Mumbai to live in a slum and earn a living. And he was my driver. And, she's cooking with firewood and dung. I told you how it's polluting the Himalayas. Of course, she's not doing it to pollute the planet. She just can't afford to do anything else. And I was holding her child. Normally, otherwise they hold the child and cook. 3 million die every year, just inhaling cooking smoke. So my existential threat is really for this bottom 3 billion. They're all living in 1 year's wage, subsistence farming. I have no doubt to speculate, but we can discuss it. At 6-degree world, this group is not going to survive. And if 40% of the planet is going to perish, isn't that an existential threat for all of us? Okay? So I finished talking about this. I talked about business as usual. The left-hand curve is what I mean we have to go. Fortunately, there's still time to solve the problem. That's the, I would say, the beauty of this issue. The scientific community, I think, has caught it in time. Okay? So I want to talk to you, how do you go from the green curve to what I call the optimal curve? So, because of this thing, again, with the Dasgupta and myself meeting, that opened my eyes. I said, this is not a problem of natural sciences anymore. It is a problem of humanities and social sciences. So I gathered 50 faculty from all 10 campuses. And we had this thing, how do we bend the curve? Okay? Again, one thing I would like you not to forget is the time scale. By 2030, remember we have put 2 trillion tons. By 2030, we're going to put the 3rd trillion ton. With that 3rd trillion ton, and with all the gases accumulated, we are assured of 2 degrees. Okay? And if you ignore it, go to 2050, you would have put enough pollution to heat the planet by 3.5. So things have to start now. And interestingly, this group, we had to put the 10 solutions in 6 clusters. I'm not going to walk you through all of that. Of course, science solutions. But societal transformation came on the top, independent of the Pontifical Academic Group. Okay, this is just University of California faculty. So, the message I want to give, I know they're prestigious social scientists. I'm saying the problem is yours. You have to help us solve it. Societal transformation. And now I want to take you to what I am doing just on my own, individual, just as an example that I think each one of us can start solving the problem, okay, in addition to the top-down support. So that's what we call the 2 levers approach. The first curve, of course, we have to bend the CO2. There's no question. And I hear so many details about that technology is this technology, but the solution I learned from the technologies at University of California, basically Berkeley, Los Angeles, and Irvine, is that electrify all the end use. Your cooking, your burning fireplace, everything goes to electricity. and generate that electricity with solar and wind. Okay, a little bit nuclear. The problem is gone. The problem of societal behavior is not gone. Technological solution. I don't want to make it too trivial. It's going to cost. Okay? But it costs a lot of money to develop fossil fuels too. And so I'm not going to say much, but the technology is there. The technology is there already to bend by 50%. Okay? The second is the short-lived climate pollutants. Remember I talked to you about halocarbons. Black carbon, to give you an example, the soot, its lifetime is 1 week. If you eliminate soot formation from diesel and not burn firewood, its climate effect is gone within 2 weeks. Ozone, which is a major greenhouse gas, a pollutant that causes asthma, it's gone in 2 months. What do you need to do? Kill the ozone? Stop emitting NOx. See, the thing about CO2 is that it's something you have to emit, you have no escape. Other pollutants, you don't have to. You can still maintain your same standard of living. So methane is 11 years. So what they showed was that you can see this, the observations is there. By the way, you can check me on this. We predicted in our paper by 2015 we would reach 1 degree warming. The planet is already warm 1 degree. And we made the prediction by 1.5 by 2030. And 2050, I won't be there. I want all the young students. When you hit 2 degrees, hopefully you know, I heard this from this old Indian professor told us. Okay? So watch that. The whole world is thinking, cut CO2, we're going to cut the warming. We reduced CO2 in 2020. Its effect didn't show up till 40 years, the dashed line. Because it's long lifetime. And the second thing called technology diffusion time. Even if you invented the magic technology, it's going to take 30 years. So I'm so feeling sad. 90% of our community said, just cut CO2. Imagine, we have to cut CO2, don't get me wrong, otherwise there's no hope. But if you fill the false dichotomy, imagine you're living in 2050, the planet is still warming by 2 degrees. You're going to think the science is wrong. So the only way to bend that curve, immediately see the black curve, cut the short-lived climate. So you need to do both. We have 2 hands, that's why God gave us 2 hands. One to put the CO2 lever, the other to the short-lived pollutant. So, but it turned out, I was focusing on the wrong thing. Till 4 years ago, I was focusing on the central value. Just pulling those 2 levers still gives me 10% probability of going to 5 degree warming. So to really cut it, because we have delayed it, we need to take that CO2 out of the air to stay in the safe zone. We still have to prepare for 1.5, 2 degree warming. The green curve, unfortunately, the amount of CO2 to extract is 1 trillion tons. For the next, starting from 2030, we have to draw 60 billion tons a year for the next 60 years. It's doable, but it's going to take enormous public support. So this was the email I told you I got in Maldives. I want to say something about this Pontifical Academy. It's probably one of the most important academies I know of, without saying anything about any other academy. Because, first of all, it's international in scope, multiracial in composition, and non-sectarian. Okay? So it's about 5 years after this, I had the good fortune of meeting Partha, and we organized this meeting. At the end of this meeting, Partha and I were asked to brief the Pope. So there are 2 major things wrong about this picture. 2 Hindus advising the head of Catholic Church. And the second thing which is wrong about this picture is we were supposed to meet the Pope in where popes receive you. Most spectacular hall I've seen, frescoes and paintings. This Pope just got out of a small car appeared in front of us. I was just dumbfounded. Fortunately, Partha spoke first, and I was not listening to what Partha was saying. I'm thinking, what am I going to tell him? Because we were given 20 minutes to change to 2 minutes. So I told the Pope, what I call now parking lot pitch, that the climate change problem has become serious. And the second thing I told him was, most of the emission comes from the top 1 billion, and the poorest 3 billion. They're going to suffer from this. And the moment he is smiling, he asked in Spanish, what can he do about this? So I looked at the Chancellor Marcello and asked him to translate me, and then I told him, I think one of the stupidest things you can tell a head of a Catholic church, which is I told him, you're so famous that if you just include in your speech, ask people to be good stewards of the planet. And Marcello later, he's smiling because that's what he's been saying last 30 years. So, and I'm pushing that to get public support. So in the US, I'm talking to churches, and my small breakthrough will come next week. So this week is momentous for I'm trying all this so that I say that I think I'm speaking to 150 evangelicals. And the only restriction I put is that they should all sign on a piece of paper saying they're climate skeptics. And so I want to find out what their scientific problem is, what the issue is with climate change. So I have a feeling this is the way we're going to get public support. Each one of us have to speak to our neighbors, preferably churches. And why is the church issue? I was always saying climate change has become a moral, ethical issue. And Gene Stepper said, made me realize the distinction between morality and ethics. So I'm changing now. Climate change is an ethical issue. Is that correct? So the other thing we are doing is, all 10 campuses, we are developing a climate solutions course, undergraduate course, which we are hoping would be taught to more than 1 million. We are floating it in California, and we are then going to take this course to the rest of US, and then hopefully internationally. So the last thing I want to conclude is the Surya project, going back to the villages, right? And the climate connection gave an interesting angle to solve this centuries-old problem. So let me show. So we worked for 5 years to find the stove which will cut the pollution. It's still burning biomass. The reason is, at least in India, Africa too, I think, firewood is not monetized. It's free for them. They just cut the trees, okay? But this stove cuts the CO2 emission by half, cuts the soot emission by 90%. Okay, remember that it's the soot which kills them. But the problem was many have tried. They don't use these stoves. Okay? So first two are two of my daughters. And Nithya is a wireless technology super duper, and she's making $200,000 in Intel. And I told her, why don't you do something useful with your life? After 3 years of this harassment, she got fed up, quit her job, and started an NGO to work on villages. So she devised a sensor which we put on the stove. So as soon as she starts it, the sensor will document the data. And what that sensor does, so you can see here, the woman gets a loan from the bank, right, buys the stove. Nithya makes it a smart stove. And then the data comes to my lab. I convert it to carbon credits. And then the money is shipped to her through the phone. So we have tried it on 5,000 homes. It turns out if she uses stove for the full year, she gets $70. Just offsets the cost of the cook stove. And the lifetime of the stove is 3 years. So she's making money this year 2 and 3. So we are hoping it will help solve the final issue. I think I've done, let me conclude. I was going to show you a movie of the 2 hours, but let's go to the question session. I see so many young faces here. I don't think you need to wait for your leaders to solve the problem. We can do it from bottom up. I'm not saying we don't need political agreements. We need that. We already have that. The Paris Agreement has given that. So our issue is to educate our neighbors, our sisters, our brothers, and we need that massive public support. Otherwise, this problem is not going to get solved. Thank you.